Hello, my colleagues and I would like to talk to you about marine energy information organized, the PRIMRE system. For those of you not very familiar with marine energy, this is a new use of ocean space. We harvest energy from the movement of seawater and other attributes. We can harvest tides, waves, ocean currents, large rivers, and also the gradients from thermal and salinity. And we use different technologies to do each of these, as you can see pictured here. So why would we develop marine energy? As the world tries to go to renewable energy, about 80% of those needs can be taken care of by solar and wind. But marine energy can be an important part of that remaining 20%. You just have to look at the ocean and you realize how much really large energy resources out there. And marine energy in particular has some unique applications that aren't useful for other renewables. For instance, in high latitudes where solar is very slim. For uses at sea, such as powering ocean observations or offshore aquaculture. And also with some energy storage and microgrids, we can power remote coastal areas and islands that are normally supplied with electricity by imported diesel. But in order to develop marine energy, there's a lot of data needed in many different types. For instance, the technologies, we need data on designs, testing, and performance. We need to know how much resource in terms of energy is out there, the waves, the tides, etc. We need to develop responsibly, so we need to understand potential environmental effects, whether animals will collide with the machines, underwater noise, changes in oceanography. We need to develop models and software codes and make them readily available. And we need to develop standards for certification and international sharing. And all of these really require an integrated data system that will allow for data access, dissemination, and also integration of data types for analysis. With this in mind, the U.S. Department of Energy directed 3 of their national laboratories to create a system for U.S. data that also includes a lot of international data. And besides the actual data and information in the PRIMRE system, or the portal and repository of information on marine renewable energy, besides those data, we have marine energy basics, webinars, educational tools, and so on. And PRIMRE is made up of a series of knowledge hubs, which you see around that central icon there. The 7 knowledge hubs that make up PRIMRE have different kinds of data and information in each one, and they're stored in different formats to suit those data. All of them are cloud-based for storage and retrieval. MHKDR hosts the tabular data. TETHIS hosts documents on environmental effects, while TETHIS Engineering has the same, but for technical and engineering topics. The Marine Energy Software Hub has a lot of open source and commercial software. We have guidance documents. The projects database allows you to search for projects and companies and devices anywhere in the world. And the Marine Energy Atlas hosts GIS layers of the energy characterization for generation. There's a one-stop shop in the central PRIMRE hub that allows you to use keywords and find the kind of information or data you want in any format in any of these knowledge hubs. We work on the cloud, as I said, and we are working towards a data lakes paradigm where we can bring together all of the data together without barriers. And this allows for better collaboration. Everyone has the same data, and there's a whole lot of different ways to access that data. And by doing this centralized data system, we really reduce duplication of efforts, we reduce transfer times, and so on. But in order to use data lakes effectively, we need standard data. And as we know, raw data comes in many different forms. It's often hard to find, it's messy, it needs to be cleaned, it's difficult to analyze. So we have created data ingestion pipelines to create standardized data that are searchable, they're clean, they're easier to analyze. The marine energy data pipeline in particular we've created using data standards, various codes, and customization puts out standard data that can be used in the data lake for a whole variety of analytical purposes and tools that are built in with it for Jupyter notebooks, for various kinds of transformation, data mining, and analysis. We are also working very hard on encouraging data sharing, both in the US but internationally as well. If we do achieve universal access to data. We're not restricted by proprietary platforms and licenses. The data become actionable and discoverable by a wide variety of researchers in industry. And we really have learned from other industries we can accelerate analysis and innovation this way. It also makes it much more democratic. Everybody with an internet access can access big data. You no longer have to have high performance computing at the big institutions like national labs and large universities, but rather schools, smaller universities, and startups can benefit. PRIMRE's been working very closely with other nations to create this interoperability with data formats we've shared. And this is just a shot of an international GIS database we are bringing into PRIMRE that shows the marine energy projects around the world. We're taking that over from an International Energy Agency committee. We all know there are many barriers to accessing and sharing data. We know about the technological ones, the things like data transfer speeds and computing requirements, but we also recognize there's many other barriers that are organizational, financial, cultural, and so on, and we are working to overcome those as well. So what we've put together is organized marine energy so it's accessible to everyone, very transparent, both in the US but internationally. This is our PRIMRE team. I want to thank you for listening today, and I look forward to your questions. Thank you.